So within one business of MacDermid Alpha, we have 3 divisions. We have the Circuitry Solutions division. Their products are MacDermid Enthone, Semiconductor Solutions. We have Alpha, MacDermid Enthone, Compugraphics, and Kester. And we also have Assembly Solutions, where we have Alpha and Kester as family brands. Next. So some key facts here. So as a $1.2 billion business, we have the resources to support long-term partnerships. We operate, over 30 countries, have a strong footprint, lets you expand globally. We also have staff that provides local support to over 10,000 customers. We have 2,200 employees, of which a lot of the connections and subject matter information, backgrounds are all valuable and are utilized. And as 50% or more of our 2,200 employees are in the innovation, technical, and service roles. Next. One of the interesting things is, very unique, is we touch every aspect of electronics manufacturing, from the design of the wafer through the circuit fabrication, the component assembly, original equipment, and device end use. So from a chemistry perspective, we're through the cross section of most electronics that are out there. Next, I think so. This is one cross-sectional cartoon of some of the products that we offer, some of the areas that we focus on. So in the semiconductor solutions, you can see, I'm not going to go through all of them, but from imaging through die attach, fine pitch solder paste, the copper side, RDL layers, Damascene copper. On the assembly solution side, you have the solder pastes, fluxes, preforms, specialty alloys. And then on the circuitry solutions side, on the bottom left, you have basically IC substrate and PCB manufacturing, right? QFN adhesion as well, and QFN tin plating, as well as copper plating and solderable finishes. Next. All right, so that brings us to the divisional focuses, where we start talking about each of the divisions. First up, we have Rich Ritalik and Rich Bellamere. Rich Bellamere is the Director of Electrolytic Metallization for MacDermid Alpha Circuitry Solutions. He has a bachelor's degree in chemistry from RPI and has been with MacDermid Alpha and legacy companies for 32 years. He's worked in research and technical service across various industries, including plating on plastics, general metal finishing, photovoltaics, PCB fabrication. In his current role, Rich is responsible for the commercial implementation of new electrolytic processes for the PCB and connector industries. We also have Rich Ritalik. Rich is a global director of electronic specialties at MacDermid Alpha. His responsibilities include the marketing and development of process solutions for interlayer bonding and etching used in PCB fabrication. Additional responsibilities include developing solutions used in other electronic assemblies, such as MID, LED, semiconductor, and IC substrate product lines. Rich has been with MacDermid Alpha for over 35 years and has authored numerous papers and presentations delivered at various industry forums worldwide. So with that, Rich, the stage is yours. Thanks.
Okay, so I will start off. Again, my name is Rich Ritalik, and I'm going to start the Circuitry Solutions Division group by outlining our portfolio of products for lead frame packaging. So MacDermid Alpha offers a full portfolio of solutions for lead frame packaging. Many of these are long-established products, electroplating products, silver, tin plating, nickel, palladium, gold, all for solderability and wire bonding. However, newer, more innovative solutions, including our PackageBond, package prep, and package plate, were developed to offer enhanced reliability and maximize functionality in the package itself. Next. I'm going to quickly plow through this slide because each one of these things I'm going to go into detail in my subsequent slides. So PackageBond HTU offers improved EMC adhesion, enabling MSL1 reliability. Package Prep CE Tin S offers tin plating on the sidewall of a singulated package, also for reliability enhancement. And Package Plate is a newer product line. This is a sequence of products that utilizes the real estate of the epoxy mold compound for increased functionality. Next. If we consider our PackageBond HTU process, this is a metal surface treatment enhancing the bond between the epoxy mold polymer and the metal substrate or the lead frame. This, again, improves a stronger bond between these substrates. It also is designed to eliminate or reduce the bleed associated with die-attach adhesives, and it leaves a clean surface for improved or enhanced wire bonding. Next. The important benefit of PackageBond process is that it enables MSL1 reliability. PackageBond provides both a mechanical and a chemical adhesion enhancement. Mechanical roughening provides a surface into which the mold compound can diffuse, locking the EMC into the lead frame surface. The organic coating associated with this process also improves the adhesion, but it provides a barrier that actually minimizes or prevents moisture ingress. The combination of adhesion and moisture ingress provides MSL1 reliability and prevents delamination. Next. Our package prep CE tin process is an immersion tin process that plates the exposed alloy leads after singulation. The immersion tin increases the solderability of the sidewall, allowing solder to wick up the side of the terminal. A solder fillet or foot is formed that can be detected and confirmed by AOI, and that eliminates the need for expensive and timely X-ray examination. Next. Next please. And finally, our package plate process. This is the newest offering in our portfolio for lead frame packaging. Here, the fabricator can take advantage of the unused real estate offered by the epoxy mold compound. Package plate process can provide antenna on package, package on package, or selective or conformal shielding options. Next. Now, in addition to the increased functionality, the package plate process offers a thinner package design. Shown here, you can see an option to replace a traditional wire bond. This technique forms vias through the EMC to the die and to the lead. And the plating thickness can be adjusted to allow for power package opportunities. So this is a really exciting development that we have ongoing, and we look forward to promoting it further. So that's it for me. Rich Bellamere, you're next.
Hey, hi, everybody. My name is Rich Bellamere, and today I'd just like to present several of our new electrolytic copper technologies that are basically targeted for the advanced IC package technologies. So IC packaging, like everything else within the electronics industry, continually trends towards miniaturization and higher functionality. And this requires, higher density packaging schemes. So this requires, from our standpoint as a chemical supplier, specific types of electrolytic copper metallization processes in order to enable these technologies. Next. So this graph here is a good illustration of how substrates, fabrication techniques, and the electrolytic copper processes offered by MacDermid have evolved in order to address the needs of finer lines and spaces and the issue of heat management as components are packed more tightly together within packages. The vertical axis shows how the starting copper foil thickness has decreased over time to more carefully control the copper budget to minimize the amount of copper that's ultimately needed to be etched. The rectangles illustrate how the evolution of fabrication techniques to attain finer lines and spaces have progressed through conventional HDI type fabrication techniques through any layer to MSAP, and finally to the embedded trace and 2-in-1 RDL plating. And then finally, along the tops of those rectangles, you can see how our product offerings have progressed to enable these different types of manufacturing techniques. Next. So there's three basic systems that I'd like to highlight today. the one I'd begin with is the Systek ETS. The Systek ETS is a DC acid copper plating process that's specifically designed for embedded trace applications, made for the routing of high density IO signals out from the die. This process is a pattern plate process that provides a very high coplanarity of traces and pads, typically less than 2 micron height differential. And it's important for reliable connection to the IC die with minimal warpage, to prevent die cracking, as well as consistent, reliable buildup of the subsequent RDL layers underneath. The resulting trace profile is highly controlled and square for controlled pedance applications, and the process is production proven, and all process components are totally analyzable, for complete system control. Next, please. The next system that I'd like to talk about is our Systek UVF and MV processes of chemistries. These are electrolytic copper chemistries that are specifically designed for the 2-in-1 plating of RDL structures that consists of microvias, fine lines, and in some cases, laser drilled X-vias. These processes are pattern plate processes that give very high coplanarity of pads and traces, along, again, with highly controlled trace profiles. The main difference between these chemistries is that the UVF was designed for smaller features and the MV series was designed for larger features. Next, please. And then the final process that I'd like to illustrate for you is a system that we use for heat management. The Systek THF process it's a single step through hole filling process that can completely fill through holes in a single step in a single solution. This process has the capability to fill both laser drilled X-vias, mechanically drilled through holes, while minimizing the surface copper in order to maintain fine line capabilities. This process is applicable to panels of upwards of about 0.6 millimeters thick, though it is preferred in applications of less than 0.4 millimeters. It can fill very low aspect ratio holes and consistently reduce plating times by 50% or more. The primary application for this system is the through-hole filling of core layers for further stack buildup and heat management. And that's all I had. Next.
All right, so up next we have Senthil and Brian Goki. Senthil is the Director of Commercial and Product Development for Die Attach Materials with MacDermid Alpha. He's responsible for portfolio planning, roadmap, and strategic marketing function in the Semiconductor Solutions Business Group. He has over 17 years of experience in marketing, product management, engineering, technical service roles in Americas and Asia Pacific region. He received his MS in engineering from SUNY at Binghamton. Brian is currently the global line of business manager for advanced interconnect metallization within MacDermid Alpha's Semiconductor Solutions Group. In his role, he worked with global OSATs, IDMs, foundries, and tool OEMs in support of MacDermid Alpha's electroplating solutions product line. He is a subject matter expert in gold electroplating and has enjoyed close to 30 years in the semiconductor industry, performed multiple roles within packaging related to electroplating interconnects, and mostly recently focused on marketing MacDermid Alpha advanced packaging materials. So Brian and Senthil, the floor is yours. Thanks.
Yep, thanks, Eric. Hey guys, hey afternoon and evening, wherever you guys are. So I'm going to kick off the semiconductor business units products portfolio. So this is basically talking about die attach, and that's kind of one of the core focuses for us. So conductive die attach technologies. We basically have products starting all the way from standard materials, low thermal, 2 watts, all the way to 200 watts. Some of them at the far end are basically our hybrid silver sintering and sintering technologies. So these are extremely high silver fill systems that offer high reliability and high thermal performance in packages. So these are kind of our newer technologies. Today we'll focus on our latest film technology. So we have films starting again from like 2 watts, which is around our standard thermal, all the way up to 100 watts. So we'll touch a little on some of the latest film offerings today. All right, next slide. So the markets for die attach is pretty much all the key areas where there is a need for high performing materials for heat dissipation, electrical performance, as well as high reliability, right? So telecom or 5G, that's a key market space for us. There's obviously automotive, where there's high power or automotive power applications, as well as connectivity. In mobile, there's mostly a lot of connectivity, amplification, power amplification for for Wi-Fi and other connections, and also in the industrial space for high power packages and applications. Next slide. So what are some of the drivers for high thermal film? So you probably heard the word wide band gap semiconductor, right? So basically GaN, silicon carbide type technologies. These are technologies that are taking more share as things are getting more efficient and the power needs are increasing. So we do see a lot of need for thermal management solutions for such type of technologies. The other area we see a lot of need is also where there's multi-die, multi-packages. So basically functional integration of multiple devices. And also in 5G space, there's a lot of cavity-based packages where we are basically packaging more silicon or more basically any kind of wide bandgap semiconductor into thinner spaces, tighter spaces. So that's kind of the key drivers. The good thing about film is it's a very neat solution. It offers less problems that typically are associated with like die attach paste, like like bleed out and filleting issues and stuff. Especially when things are getting thinner. Today wafers are 100 micron or 4 mil thickness is very standard. We also see like some in the 50 micron range. So as things get thinner, we do see a need for a much more higher efficient solution, and conductive film really is the key solution for that. So that's kind of some of the key drivers and the benefits obviously of using a film die attach versus paste. Right, next slide. So this is our portfolio of film offerings. It's basically categorized into 4 different film products that we have. So on the left, you have the CF107B, which is like a 6-watt film. And if you look at the thermal conductivity from left to right, we are focused on a 100-watt or try to exceed 100-watt with our latest CF300 series. And this is going to be one of the highest thermal conductive films in the market. It's focused on all types of wide bandgap technologies again, and enabling high reliability in packages. So this is basically where we are today, all the way from 6, kind of pushing 100 watts for thermal conductivity. Right, next slide. So in summary, we have basically a couple of films, CF107B and 1D, which are in production today, qualified for multiple applications where there's a need for high-end packaging, tight spaces, and thin wafers, multi-die, stacked die. CF250 is basically being used for large die applications, especially for RF type 5G base station. And then CF300 is the latest and greatest, which is over 100 watts. And we have opportunities mostly in the telecom space today, but we are also looking at a lot more opportunities that are coming through in automotive as well as in the mobile space as well. So this is basically focusing on high reliability die attach solutions for demanding power applications today. Right, that's pretty much what I had, and I think Brian's next. Next slide.
I am next. Thank you, Senthil. Welcome, everybody. Thank you for joining us. I'm going to introduce less about the products and a little bit more about where we're going and how we got there. My name is Brian Goki. I'm the product group manager, as Eric mentioned earlier, primarily focused on electroplating solutions. So let me just move into the So let me say this. So on this slide, it just shows that we have quite a few products all the way from Damascene through gold electroplating. Next page, please. Sorry, I was trying to hit page down. Sorry about that. Yeah, so customization of previously standard materials is being driven by a diversity of new package types and many times green initiatives. So the technical roadmaps and the fundamental technical drivers share commonalities like IO pitch shrinkage, IO density increasing, higher functionality, faster performance, thermal management. But even though there's a lot of commonalities in this space, right? There's 5 different package names here with a multitude of players in the field, and they're all moving in the direction of smaller pitch and higher density. So the problem here is that the packaging roadmap is not unified. The end markets are vast, and the package designs are varied. So therefore, really greater customization and partnerships of developing solutions that fit the needs of these users is really needed. Next slide, please. So how are we meeting that challenge at MacDermid Alpha? Well, we develop and synthesize our own custom polymers. Really, this is driven by our fundamental understanding of EChem modeling. And this enables finer pitch and higher densities that are really how you get the key performance from these materials is through synthesis and customization of the polymer to get coplanarity, TIR, so within die, within feature shape control. Also bottom-up fill mechanisms are modulated here. And grain structure, like you see on the right-hand side, that's a 1-1-1 oriented nano twin grain. And then throughput. There's also some other drivers and how we're developing things. Alternative materials to meet the environmental landscape. So we've developed boric acid-free nickel, formaldehyde-free coppers. Of course, we're in lead-free solders. And we really do this, through a library of our novel polymers. So next slide, please. So here I just wanted to kind of show the same slide as before, compliments of Yole. Thanks to them, they gave me the slide to use earlier. And so I developed it to show the same package schemes and how we're trying to focus on those with different chemistries. And you can see that there's quite a few chemistries now that have been developed from high density fan out. We have many applications there for coplanarity and RDL needs, all the way up to a nano twin copper for hybrid bonding that we think could enable a lower temp copper to copper bond. So I think it's very interesting technology. We have lots of different products that we can discuss in the future. So if you have any questions, please reach out to me via email or phone or LinkedIn, and I'd be happy to share more information. Thank you. Thanks.
Hey, great job, Brian and Senthil. Awesome. All right, so next up we got the Compugraphics Photomask group, and we have Craig Durkee and Peter Maitland. Craig's an icon in the photomask industry. He has over 40 years experience. He fosters the best connections for matching capabilities to needs and exploring the technical and logistical solutions available. Growing with each customer and supporting change as the demands of industry continuously evolve. That's Craig's long-term goal and passion as a director of the US sales team at Compugraphics. Peter's an industry veteran with over 30 years of photomask experience, including roles in lithography, quality, mass design and layout, applications, and business development. As a business development manager for Compugraphics, he works with design engineers and photolithography professionals throughout North America and Europe, and utilizes his comprehensive experience to recognize opportunities to help our customers Pete's professional connections to wafer fab equipment manufacturers and suppliers make him an especially unique resource and a catalyst to technical solutions and new business relationships. So welcome, Pete and Craig. Thanks, the floor is yours.
All right. Can folks see me?
So if you guys don't, Craig is at a real bar.
Can you guys see me okay? Yeah.
Yeah, we see you good.
Okay, sorry, I lost the view. So thank you, Eric. I appreciate it very much. And I'm an icon now, huh? Okay, that's another way of saying I'm an old guy. But I have been doing this a long time, and I'm here to give you a little overview of Compugraphics Photomasks. We're a global photomask supplier. We've been supplying primarily the electronics industry now for over 50 years, actually, starting back in the 1960s in Scotland. And we evolved into the United States in the late 90s. We specialize in high quality for quick turn photomasks. You'll see that we cover technology that's largely in the mainstream, established technology, and we concentrate on service, which is what part of what Eric related there in my bio. That has been my focus throughout my career, is to work on connecting where people have particular issues or unusual fits where they need photomask solutions. This is an overview on this slide of what our primary products and services are. You see in the first section, we cover all the standard stepper reticles, including some not mentioned there, and also the Ultratech 1-to-1 steppers that you might be familiar with. We also make masters, which are 1x photomasks used in contact or proximity aligners. And we cover large area photomasks, particularly 14-inch and larger even, that we're capable of making. We still service submasters and copy plates, which is if people are doing large volumes of low quality, low end technology type applications, where the quality of a copy is tolerable when you're doing large volumes of the same exact photomask. We also specialize in pellicle replacements and photomask cleaning services, particularly in the US, where we offer a facility that's a standalone facility in Austin, Texas. It's a one of a kind. It specializes in same-day cycle times, and it's really the only one that can do that routinely, although we offer the same services from our other facilities. And we do mask recertifications, which is another process where people want to check the integrity of their masks that may be in storage for quite a long time in production use. They want to check to make sure the integrity is maintained so that they still meet the quality required. So we do those routinely for some customers that send them to us every so many months or years in storage. We have a unique product called MPT, which is an anti-stick mask coating. This is for people using contact printing for their liners, and it reduces the resist sticking to the photomask, which of course cuts down the usage or increases the number of cleans that people have to apply to the photomask. So ours is a unique one. It's a one of a kind. We're the only ones that offer it. We also specialize, as I said earlier, in quick turns, although we also get down into very fine resolutions into submicron, as you'll see on the next slide. And there's the next slide. I spoke a little too soon, but I also wanted to mention we do direct write as well as OPC, optical proximity correction, and we do grayscale. Oh, thank you, appreciate it. Grayscale as well, which is an application where pixelization on a binary mask can achieve gray sort of results that can be used in various process applications to help people in their process. Next slide, please. Thank you. This gives you an idea of our capabilities. I'm not going to dwell on all the details, but as you can see, we cover all the standard mask sizes and beyond into the 14-inch realm, which, as I said, we have been doing now for some time. And the 5 nanometer represents our finest grid size. So that is not the smallest line we can resolve, but it is the pixel size, or the address, as they call it, that we write our laser tools will write with. And this gives an idea of the kind of resolutions we can achieve, which in a production mode, we can easily get down to a 0.5 micron line size. And we can get down to hole sizes that are in the area of 0.7 micron. But again, all these specs you're looking at, and again, I won't dwell on all of them, but as it says here, these are just production worthy stats that typically apply to any application a customer may have. We are capable of doing beyond this, and we're happy to talk to people in our interest in working with customers' special needs. And as you also see, we do work with all standard data formats, and we provide online capabilities to entertain quotes and to process orders online as well. And we also offer shipping confirmations, tracking details, so that our customers, because this is a quick turn business, customers need to know when we got it and how soon they're going to get it, where is it now in the process, and they can do all that in many different ways, but they can do it online, real time, and that's typically part of how we win the satisfaction of our customers, is by being responsive and available. Next slide, please. And this is just a quick summary again of when you're working with Compugraphics, quick turn is a big focus for us. 24-hour to 48-hour is pretty standard stuff for us. And it's something that when you consider we're getting custom data from a customer, it's quite a task, but it's something when you do it long enough and you listen to your customer, you realize that it's something you have to do, and we do it well. As I mentioned earlier, we have multiple sites globally, and here on the right you can see in the photos, our US manufacturing site is in Fremont, California, located just outside of San Jose. And we focus on a lot of Bay Area customers still for that reason. And our other US site is the service center I mentioned earlier, where the pellicle replacements and the mask cleaning is their specialty for same-day turnaround. They receive it in the morning, they turn it around in 4 to 6 hours and ship it out that night. We do a lot of counters where it's necessary, because many people, when they have a pellicle damaged in their Photomask line, or they have a plate that's gotten too dirty for them to clean or to be able to use in the process, they need it quickly. So we understand the immediacy of these orders, and this is all that this site does, and it's got a huge reputation for reliability and consistency. And then working over to Europe, our original site located in Glenrothes, Scotland in the UK. That facility mirrors essentially our US Fremont facility. They have almost identical tools or very similar tools, and we are matched into them, which we exercise regularly to make sure that we can actually manufacture even parts of the same device in 2 different locations if necessary. This also gives us, obviously, backup to each other as needed. And we also have the Jena, Germany facility, former ML&C operation in Jena, Germany. And these are the guys that do the 14-inch plates for us, do a fantastic job with large plates as well as other applications. And they've also been around for a long time. As I said, Compugraphics started in Scotland in 1967. And we also have a service center in Singapore. Although we're not currently manufacturing in Asia, we actually do ship routinely into Asia from both our site, or all 3 of our sites, I should say, actually. So it is something that we're doing regularly, and we're trying to develop that business actually with the service center we have there, and it's actually been very vital for us in recent years. So another couple of details that I would just mention is, with the current conditions in the industry, with the supply shortages that a lot of people have been concerned with over the last at least several months or so, as the pandemic starts to lift, we've been finding a lot of people are really taking comfort in having additional sources. So if you're not already working with Compugraphics, certainly it's a good option to consider another capable source. And Compugraphics really has been servicing people in semiconductor, optoelectronics, photonics, biomed, just about any electronic related or optical related industry and others. And having alternative sources is a very good idea right now. So we're finding, that a lot of people are talking to us about providing that alternative source. And for those who already know us, we concentrate on service, as I mentioned from the beginning. So the real message is, we did a voice of the customer a few years ago, or a couple of years ago, actually. And the results of it were extremely positive. We had some of the highest ratings that the survey company had seen. So we know that once people give us a try, they see that even for small customers, small or large, we're very responsive and service oriented. So that's the main message: quick turns, unique service. And with that, I'll turn it back to Eric, but Pete is also going to be available with me to answer questions.
Oh, great. Hey, thanks, Greg. Great job. All right.
Thank you.
Yep. All right, I'm going to introduce Gyan Dutt. Gyan is a global portfolio manager for power electronics within MacDermid Alpha in the US. He is responsible for portfolio planning, roadmap, and strategic marketing function in Power Electronics Business Group. He has more than 15 years experience in marketing, product management, applications engineering, and technical service roles in the Americas and Asia regions. He received his MS in Materials Science from the University of Tennessee and an MBA from UCLA. Welcome, Gyan, and the floor is yours. Thank you.
All right. Thank you, Eric. Can you see me? I cannot see myself for some reason. Can you hear me?
You. Yeah, I see you and hear you. Yeah, you're clear. And
oh,
your
all right.
slide is
Very good. All right. Very good. So thanks for the kind introduction, Eric. I'll start out with a high-level overview of the portfolio for the Assembly Solutions business. And as you can see, we do a wide variety of products for which I'm not an expert for most of these. So starting out from the left-hand side is the biggest chunk, which is around SMT technologies. So essentially, this consists of all the solder-based products, the solder paste, the wire, and some of the process solutions that go into implementing solder paste on the machines. So these pastes are mostly around printing. Also, lately we have seen a lot of pull from the jetting materials as well. And then coming to the middle section is the power electronics packaging and assembly business, from where I come from. Essentially, there are two different product areas. The first one is, of course, around sintering materials. So these are materials that are pure sintering materials without any fillers or resins, which make pure diffusion bond. So Argomax is the industry-leading brand in form of pastes and films, also engineered products. We supply the materials which are in sort of a easy to handle pick and place preform format, bond buffers, also pre-laminated to clips. And of course, we also draw upon Semiconductor Solutions ATROX product line, which provides hybrid sintering without the need for pressure in the press. Apart from the sintering materials, there are, of course, solder-based products. The two key product technologies or product groups that I want to mention are related to our proprietary bond line control technology, which is the True Height, for which we do preforms and ribbons, and also we do high temp alloys under the name PowerBond series. And then there are a couple of other product groups outside power electronics, which are related to adhesive solutions that are geared towards mostly mobile applications. And then there's another newer area, which I won't go into more detail, is related to printed electronics, in-mold electronics, flexible electronics, that sort of stuff, for which we are developing a series of inks and solder pastes to support assembly at low temperatures, flexible assembly on different substrates. Okay, next slide, please. So essentially, for power, we supply for all the applications, okay? Starting from the consumer side all the way to industrial. If you go into high power, high frequency, kind of applications. But 95% of our business is in automotive space. That's right down in the middle, and which of course is growing rapidly with EV revolution. So there, the key drivers are efficiency. So you need to take the power from the battery, the lithium-ion battery, and convert it into the AC power to drive the AC motor. Okay, and you have to do it at 98-99% efficiency at high temperature for millions of cycles. So power density is important, form factor is important, of course, reliability and efficiency is important. So at the bottom, you see all these packages that we are into that are responsible for driving all the high-end EV brands that you see out there, including the biggest and the most well-known brand. So these are used to these materials are used for the die attach part, where you bring a die down to the substrate. Then there is attached to either a base plate or to this heat sink, which may happen with solder, as well as the sintered material solution. And then on the industrial side, we also have some special form factors like films that go into making thyristor attach and IGBT press packs that are used to deliver power over long range through HVDC form and other forms over long ranges. Next slide, please. So going a little deeper in the power electronics space, the key drivers onto the left are, of course, high temperature operation and efficiency with silicon carbide and gallium nitride devices. And in case of automotive EV space, with the traction inverters, silicon carbide is rapidly gaining traction, no pun intended. And for simple reason that the higher operating temps that come with these kind of materials, they bring the efficiency and reduce need for cooling. But at the same time, with higher operating temperature come challenges which are related to CT mismatch, and also the requirements for EVs, since an inverter is essentially the heart or the engine that drives the vehicle, has to be fully reliable. So those requirements are going up, and customers routinely demand for 2 million power cycles. So the materials need to catch up and provide the efficiency and the reliability to operate in that kind of environment continuously. So at the bottom, you will see some of the packages and the inverters that we are in, and that support that form the heart of the EV drivetrain for some of the biggest brands. In the middle, there's some information about our solutions, which are essentially pastes and films made from our proprietary nanoparticle technology, which is the Argomax platform. So these are available in the form of films, which can be used for die attach on at the die level. They can also be used at wafer level. Of course, there are pastes that are used at die attach level, also at the inverter assembly level. And then I also mentioned ATROX, which is a preferred solution when somebody wants to do a pressureless solution with hybrid sintering with the existing equipment. And then moving beyond sintering materials, we also have a couple of unique solder-based solutions, which are around bond line control technology, which is the True Height line, which is used to control the bond line and ensure consistent planarity and reliability of the MOSFETs that drive some of the most well-known electric vehicles. And also the PowerBond series of alloys, which are tin, silver, copper, antimony-based alloys, which are highly creep resistant and are used for high temperature operation, 150 to 175 degrees Celsius, with the IGBT power modules. Next slide, please, Eric. Okay, last but not the least, the board assembly interconnects portfolio, which is honestly the largest piece of the business, and we have the dominant market share. Some of the recent innovations are around increasing automotive reliability with proprietary alloys, and these include Maxrel and HRL series of alloys. Maxrel or Inlot especially enables improved thermomechanical reliability in harsh operating environment, which enhances performance over very long lifespan required for automotive applications for both powertrain as well as for safety systems, right? And the focus, especially for these alloys, going beyond the alloys into the paste format lately, has been to enable, the fine feature aspect of these things, so that you can print down to very small feature sizes, but still pass the SIR requirements with very low standoff, things that are getting very common with mobile devices, with wearable devices for next generation assemblies and next generation complex assemblies, which require assemblies on board as well as plastic substrates. So this is sort of a high-level overview of the achievements or new initiatives, product initiatives on the circuit board assembly side.
So, thanks for that overview. It was good. I hadn't seen these slides before. I think to save some time, we have like 10 minutes left. That was your last slide, right? Ian?
Yep, I'm done. Handing back over to you, Eric.
Hey, thanks. And we'll talk about University of Tennessee and Florida Gators later,
All right.
So, hi everyone. So let's go ahead and open the floor for questions, or open the lines for questions. I know there's a handful of folks out there. So anybody, some of these came in from online as well. So let me pick one out real quick. Okay, so here's one. So this is to semiconductors. With respect to convergence, is MacDermid Alpha beginning to see overlaps in the different technologies? And that's to Brian and Senthil. So with respect to convergence, is MacDermid Alpha beginning to see overlaps in technologies?
Yeah, sorry, I just turned my mic and video on. Yeah, I think so. And I think that the ES guys can talk to this too. Probably more of the convergence we see is on panel level, right? Where we see traditional printed circuit boards moving to panel, and then some wafer applications moving to panel. And so there's a convergence there, which we're very aware of, and our team works together in that cross-functional space, if that's the convergence we're talking about.
Yeah, and in fact, there was a question on panel, which was, one second, another one up here. Yeah, so in the ETS process, this is for circuitry. In the ETS process, what kind of thickness variation can you expect across a panel? So that's for Jim and Rich.
Okay, again, from a panel level, view. When you're in one of the the panel level plating tools, the ETS system across a like a 500 by 510 millimeter panel, you can expect right now somewhere in the range of about 3 to 5% variation across thickness variation across the panel itself.
Gotcha. All right. Anybody online have any questions?
Everyone can feel free to unmute themselves at this point and, put your videos on, and let's just have some, open conversations.
Hello, this is Gabriel Formicon with Integra. I think I've had a little bit of interaction with Craig for Photomasks, but
yes, hi, Gabriel.
Hi, I don't have, I'm basically have these extra screens on my laptop as the video, the monitor down. I don't have the camera. Sorry about that. But the question I have is, first of all, thank you for the very broad presentation. It covers so many different topics at the same time. Some of them really caught my attention. I was wondering if we, as the attendee, can have a set of slides. For instance, I was looking for some information on the different topics related to the die attach, some of those sintering material paste that I've seen on the slides. So maybe I can follow up. Once I review the slides a little bit better, I can formulate a little bit better questions rather than, attempting to ask questions that probably are not necessarily accurate.
That's understood. And yes, we can provide that, right, Eric? We can provide
Yep, the deck,
the full
and then
presentation deck. Yep.
So how does the sintering paste for the automotive, for all this power electronic differ from what some people use, for instance, in the RF and microwave industry?
That's a great question.
Which is
That's a
also,
great question. Yeah.
Yeah,
was
let me try to-
Eric, we have Lenora Clark on too, if
Oh, yeah. Well,
wanna jump in on-
good question for Senthil because it talks.
Yeah, I can take that, Gabriel. Hey, yeah, thanks for the question, actually. It's actually a very good question. It's really the requirements of the industries are different. The RF side or 5G, their targets are obviously thermal dissipation is key. And then they're also looking at, high performance RF signal propagation and low latency, right? So
Yes.
The power side for automotive, it's really more efficiency. So loss, less loss, which is obviously always a challenge. So, better efficiencies through the device in terms of high power current densities and stuff. And Gyan's actually the expert with the power electronics for the EV market. So Gyan, you want to jump in and add anything?
So there are a couple of things. There's a power loss aspect of it, but from automotive, what we find is people are attracted towards the performance aspect, which is, of course, higher power density and lower loss. But the reason they really adopt the paste is the endurance part. So you can keep on going at very large delta T's at 1 million to 2 million cycles at very high currents without degradation in performance. So in terms of the specifics of the material, it comes down to essentially having a resin-free material, which is where particles come together purely by diffusion bonds. So it's all metallic with low stress. So it's very different than what you would see probably in micro-via kind of application, which Senthil might be familiar with better. So back to you, Senthil.
I was going to follow up based on that. It's not necessarily the micro-via that I was thinking of, but in terms of, so the use of this paste, does it entail the use of specific material for the package type of thing? Does it restrict, or there is, like copper flange type of packages are suitable for this, or do you have to use something more suitable for the power electronics in the automotive industry only?
It's a good question. It's not very discriminative. Today, our portfolio of die attach technologies, right, from the sintering, full sintering to hybrid sintering, are pretty much indiscriminative of the surfaces. So there is copper surface, which is very common. There's DBC, so gold, silver, most of the common metals. The only thing we probably don't have and I don't think it's going to be easy is to get a solution is for like something like nickel, right? Which is almost like a diffusion barrier of sorts. So other than that, most common surfaces have been pretty successful. And again, between both technologies, the full silver sintering and Argomax and the ATROX hybrid sintering, we can find a solution that meets most requirements.
Okay, very good. Thank you very much. I will follow up once I receive the slides. Thank you.
Thanks for joining us, Gabriel.
Thank
Good,
you.
good questions as well. Great questions. Any other questions? I got another one over here. So this is another question for semiconductors. How is MacDermid Alpha managing or navigating through the geopolitical challenges with China? Is that if Brian, you can chime in, if you guys want to attempt to.
Yeah, that one is it is pretty politically based, right? So I think that the one thing that we're trying to do is manage our relationships with non-US based tool OEMs, which is a little tricky because we've primarily had our focus on US OEMs. So those relationships are becoming a little bit more important as we're introducing chemistries into China. It seems that our business is still growing in China, and so far we haven't been as impacted as we expected. The other problem is not related to geopolitical, but really in the regulatory area, that we're seeing a lot of the regulatory needs popping up in China, specific to boric acid free or formaldehyde free, in areas that we've already developed solutions for. So I hope that covers the answer.
Yeah, anybody have any follow-up questions on that? Or whoever asked the question originally? Oh, all right, I think another question here. For circuitry, are there any special equipment requirements for the UVF and MV processes? Are there any special equipment requirements for the UVF / MV processes?
Yeah, so as far as the equipment sets for the UVF and the MV series of chemistries, a lot of it depends on the the feature sizes that you're looking at. Generally, for the larger feature sizes, you're looking at typical VCP style equipment with some just really special nozzle impingement requirements to help get the exchanges of active chemistry within the features. When you're looking at the finer technologies, then you're looking at something more like the Cisco type tools where you're looking at high jet, high speed type applications.
Makes sense. Oh, that was a good question. Deanna, how much? It's 3 o'clock. Do you have time for another question?
I think we could go as long as people want to stay on.
All right.
All
right. Yeah. So let me get. Let's see from online.
Anybody else have any questions? That can chime in? All right. Why don't we take another typed in question, Eric, and then.
Yep. No worries. This one I think it's for Gyan. There are all kinds of flavors of sintering materials in the market. Hybrid, liquid phase, semi-sintering, pressureless. Where does MAES stand on sintering technology?
Great question, Eric. So as I said, there are a couple of different flavors that we play in. The first one is the Argomax line, which is full sintering, where we essentially work with small particles, nanoscale particles, which diffuse together to form a pure diffusion bond without the resin. Of course, that happens at high temperature and high pressure, but what you get is a very high thermally conductive and very high reliability bond that can, with the reliability which is like 10 to 15 times that of solder. And then on the other end of the spectrum, we have our ATROX line of a hybrid sintering solution where we have the benefit of processing without the pressure, right, with the existing equipment, but we still get the benefits of sintering of particles fusing, although not to as high extent as Argomax, but still able to get very high thermal conductivity. So there are essentially 2 different kinds of sintering materials we play with: hybrid sintering, as well as full pure sintering assisted by pressure.
Oh, great answer. That's good.
Right, and if I can add, Eric, I mean, basically the answer to that question is like we have all solutions really, pretty much from full sintering to even liquid phase. I guess solder is a liquid sintering technology, right? So we have the different formats of solder as well. And
in paste and in film, right?
Yeah, film and paste form, pretty much. Yep.
Hey, Eric, this is Brian. Is it okay if I ask a question of a participant?
It depends on the participant.
Hey,
but I think
Dan, can I ask you a question since you're on? I don't know if.
Sure, Brian. Were you talking to me? Yeah.
No, I was talking to Jan Bardman.
Yeah, Jan Bardman's there. Hey, Jan.
Hey, how's it going?
I didn't think you expected a question on here, but here you
Oh,
go.
I didn't expect a question, but I'm happy
we're-
to try to answer. Sorry.
We're
about
trying to make it a
that.
little more interactive, but I have a question for you. So I sat on your earlier discussion about is the supply chain broken? It was really interesting. There was a lot of talk about substrate suppliers and having more interaction in the supply
Yeah.
chain from OSATs, et cetera, and having a healthy supply chain. How do you see that for, being a supplier to the suppliers, if you will, like us? Do you see more interaction or less or the same?
There should be more. We're
Yeah.
doing a lot of independent consulting as well with people doing a deep dive into the substrate issues. And one of the things that we've been asked about is, what about the materials? Are there shortages of materials that go into the substrates? And
Right.
so we've had to look at the ABF materials, we've had to look at the copper foil and some of the other materials, and it's not clear that whether there's shortages or not. We're still kind of digging around on that, but I mean, I think it's of concern to people. Certainly, in the panel, I didn't want to say this, but my big fear is that we're living in the roaring 20s.
Right.
And just like 100 years ago, after the last pandemic, we were in the roaring 20s. And my fear is that 2029 is 1929 again.
I hope not.
And so, I'm just living in this fear, and I'm trying to look at all the things that could go wrong.
Right.
And, it's so I'm looking at, okay, so, and then like we were talking about on the panel, you've got to go down to the material, all the way down to the solder mask, to the copper foil, the everything, and look at, the supply chain. And I don't know about you guys. I don't know if you're, in all the supply chain, are people beating you up on price still? Because that to me is one of the big issues. I felt like is people were just constantly pushing people hard on price. And in the last 2 years, I felt that lift a little bit.
Well, for us, localization has became the big cost down factor.
Mm-hmm.
Especially in Asia, there's companies that are starting up and trying to compete, and really all they're doing is putting us in a pricing war. They're not really a technology competitor.
Right. They're just dropping their price to try to get in the market.
Yeah. And so that's one of our difficulties, right? But
yeah, well, that would to me, to my after our discussion on the panel, I would think that would impact yield, and no one can afford to impact yield right now.
Right. Good point.
So I think that, my argument would be, look, if you have to throw anything away, it's a bad thing. Mm-hmm. Because you need to be increasing yield, not decreasing yield. So I don't think anybody's going to be willing to just pay less for something if there's any potential impact on yield. And I think that, that's really what the industry, if there's anything that I think we're learning from this pandemic, is that you've really got to improve your manufacturing process where you improve your yield. You just can't build more scrap.
Right. Good point. Yeah.
Yeah, with limited capacity, right? We're fighting for capacity. Yeah.
Thanks so much, Jan. Appreciate it.
Sorry about that. But I hope that helps. I mean, just my opinion. So.
Yeah, no, that's great. That's really great. Why we
asked you. Jim, do you have any inputs to the question? I think you're on mute still.
Oh no, I'm off mute.
Oh no,
I don't think there is. Is there a mute button for me? Oh no, Jim. Oh yeah.
Me, sorry. I just wanted to make a comment to kind of track on to Jan's comments about the whole supply chain. Is you brought up some very good points. ABF material and supply of ABF material. How does that play into manufacturing? There's certainly been, let's say, a confluence of a lot of different factors, whether it's blocking the Suez Canal, the coal rig down in Texas, that impacts the making of polymers and base materials. So from an IC substrate perspective, even from a PCB manufacturing perspective, prices are going up because we have a hard time procuring some of the raw materials that we would use to make processes and chemistry to sell to our customers, to the fabricators. Mm-hmm. So that's definitely real right now. We're coming out of it, but it's been kind of a shaky cliff for the last couple of weeks, for sure.
Yeah, I mean, so you've got it's like the perfect storm. You have geopolitical things that are going on. You've got natural disasters that are going on. And then you've got this increased demand brought on by the pandemic. And so it's this trifecta. And so that's really what we're dealing with in the industry right now. And you can't say that, I mean, I'm hoping that it gets better. Bigger increase than normally would just be from the return to, to the productivity. So, I mean, it's just a really complicated situation now. And, yeah, I think it might get better in a year or so for some segments, but,
Yep.
I don't know. It's
making its round through supply chain, right? First it was one thing, and then another raw material, and then another, and then then it's containers, right? So
right. Oh, it's all kinds of. I mean, it's like everything that could possibly go wrong has gone wrong.
yeah. I actually went to Home Depot the other day, and they're out of paint because at a Texas there's a big chemistry or big,
Yep. Yeah,
site
we're
there.
out of paint. We're out of wood. Forget if you want to buy a bicycle or bicycle parts.
Yeah.
We're out of everything. So how can this? You ask yourself, how can this happen? And it's this, like I said, it's the perfect storm.
Yep. Those great comments, Jan.
Hey, Jan. Hey, Martin. Subject here. How are you?
Hey, Martin.
Hey, Jan. I was just curious what you're thinking about Washington and how they're going to play into the semiconductor.
I just sent a note off to somebody because I have been advising some of my clients that are lobbying the government for money and stuff. And, I don't know if anybody read my article in last November in Printed Circuit Fab and Design and Circuits Assembly, but I wrote about the whole ecosystem and the importance of R&D and how in the U.S. we have some of the last tax cuts and stuff cut the tax credit for R&D for companies. And so we have a lower R&D, tax credit. There's a lot of things that are, that have to be considered. So what I've been trying to advise my clients is that you need to lobby for what we call smart spending. Just like we have smartphones, smart meters, smart grids. Okay, you need smart spending. So by smart spending, I mean that you can't just write a check for the semiconductor guys and say, go build fabs. I mean, you got to understand the whole infrastructure. There are no OSATs in the U.S. There are no major OSATs in the U.S. So you got to step back and go, okay, what is my strategy here? Do I just want to build some fabs? I mean, that's one thing. And then if you wanted to build what kind of assembly are we talking about here? Are we talking about just some defense stuff? I mean, there's some small companies that do medical, that do military, and that's fine. But what is the strategy here? So what do you want to do? I mean, Global Foundries supplies some for automotive. The automotive guys are saying, well, these foundries need to supply us because we're the one in shortage. Look, by the time they get the foundries online, which is like 2024, 2025, those automotive guys will have figured out how to get some capacity, I think. So, you can't necessarily, I mean, you got to figure out what do you want to do. And the other thing is, if you're going for advanced nodes, and I mean advanced nodes like 5 nanometer, and below, then you're going to have a need for an assembly operation that are very near the fab itself. So, and that's why you saw Intel make the announcements of we're going to expand Foveros in New Mexico and Oregon. So that makes sense. But, then you got, everybody from India saying, okay, I'll give you $1 billion if you put a semiconductor plant in. Well, there's no infrastructure there for some of this stuff. And, it's not like they haven't tried that before. Europe thinks, well, we need to have some more stuff over here. Well, so that's why I asked the question on the panel. By 2025, do we have too much capacity, which would also be a problem. So, people, you got to sort this stuff out. It's so much more complicated than a 30-second sound bite, and that's really the problem here. Is everybody wants instant noodles. Add hot water and be done. But that's not.
I think we're making progress. President Biden was holding a wafer the other day, so I don't know if you saw that.
Oh, really? I didn't see that.
Yeah. So
nobody in Washington has paid much attention to this industry and I don't care which administration you want to talk about. Nobody's really paid attention to an understanding and a comprehensive understanding in a very, very, very long time.
Not like our competitors.
The fact that people are looking at it is good. The fact that they don't understand how this is a global industry, and look at your manufacturing operations. We are in a global industry. So you have to understand what all that means. And it's just so much more complicated than a lot of people really understand. So I've been working with IPC, working with Semi, working with all these other people, and trying to do my volunteer work on trying to explain to people what's, how this picture works. But it's what the good thing is though? Packaging, all of a sudden everybody's going, oh, a semiconductor package. So that's a good thing.
And we have jobs for a little bit, right? So
we all got jobs. Oh, we're gonna have plenty of jobs.
I appreciate the call on that. Thank you very much.
Especially these guys in Phoenix.
Yeah, I'm gonna have to step off for a second. So hey, I enjoyed this so much, and we'll talk to you guys all soon.
All right.
Thanks, Ken.
Ken, I want to talk to you about nanotwins soon.
Oh, okay.
I dropped you a message on LinkedIn.
Okay, I'll get to that. Okay, thanks.
There's a question from Ved. I'm not sure if they raised their hand. Okay, great. Thanks.
I saw that.
Yeah. I just had a quick question. I don't know a lot about. I actually didn't know you had a hybrid sintering paste. But my question is, what would be the advantage of using that over something like a silver epoxy or something of that nature?
Oh, very good question, Ved. So the hybrid silver sintering paste is really a hybrid between two components. One is the polymer portion and the silver. So that's why it's called hybrid. And it is a pressureless solution. So it fits into your standard epoxy manufacturing process. The advantage really is the thermal. We can achieve thermal conductivities of up to 200 watts per meter K today with that technology. Standard epoxy is obviously on the lower side, right? Like you're talking of 10, 20 watts, maybe pushing with high silver systems. So this system offers much more higher heat dissipation capability and electrical in the package.
I see. So it would be the same, you're using like the same polymer-based matrix and then same processing.
Conceptually, it's basically, yes, it's the same polymer-based matrix with high silver system. And then there's basically the silver is kind of a unique filler, which sinters without pressure. So it's really like a thermal cure system.
I see. So you won't be compromising the strength then? Well,
no, if at all, it'll enhance it. So when you have a metallized surface, right, you're going to have like two forms of adhesion mechanisms. One is the polymer portion, and the other is going to be the silver sintering. So you actually end up with a higher adhesion strength and higher MSL temp cycle capable material.
Right. No, sorry, I meant over the epoxy. Because if you're getting the higher thermal conductivity over the epoxy,
correct,
you will also be compromising the strength, or the strength will be the same as the silver epoxy paste if I were to go out to another company and buy?
Yeah, again, that's why I think that the adhesion strength would be higher because we have two forms of it, right? We have the polymer portion, which is also a part of the system, plus the silver, which will sinter and add to the adhesion strength. So technically you get a higher strength.
Perfect, thank you.
Yeah.
That was a good question. All good questions, yeah.
Yeah, good question.
So I don't have any more questions that came in. Anybody on the line want to ask? If not, we can conclude this great participatory happy hour. And Brian, you can share your Guinness.
My Guinness is empty now. Everybody talked too long.
Dang.
Time to refill, Brian.
Oh, awesome, man. You guys are good.
Well, thanks to all the presenters and thanks to all the guests. And I'll get a list from Shelby on who was in attendance. We'll get the presentations out to them. And Jim Watkowski, our VP of Innovation for Circuitry Solutions, will be on the 5G panel on Thursday at 1 p.m. So everyone's invited to do that if they've registered for the conference. And I think we should do this again. This was fun.
That was great. I got a lot of good input, by the way. A lot of folks chiming in on a great overview.
Yeah.
Excellent.
All right. Well, thank you, everybody. And
Thanks,
enjoy the
everyone.
rest of your evening.
All right, thank you.
Thanks, Deanna. Thanks, everybody. Great job, Eric.
Bye-bye.
Thanks, guys.
Bye, everyone.
Cheers.